that we're going to be using to address different types of questions. One of the things that I see as a gap is like the long-term vision of how it's going to be applied at the Air Force level. And that was sort of something that our table talked about. And we decided that our group has a lot of experience watching what is coming out of Hollywood, so we decided to leverage some of those futuristic sci-fi concepts and incorporate them into a vision of how systems biology could be applied. So one of the things that I'm going to start with is an example. Say you have like a new airman recruit who really wants to become a U-2 pilot. One of the things that systems biology could do from like a single blood sample is we could take and figure out their genetic profile. We could look at epigenetic imprinting for that individual. We could also take and reprogram some of those cells to where we have iPSC cells, which are basically stem cells. We could then, in the lab, develop any target of organ interest that is going to be personalized to that particular individual and see how they are going to respond to environmental stressors. If you then take someone who does modeling and you have a computer program where you could input that data along with an epigenetic profile and a medical history, then the ultimate thing that you would have as your output is identifying different health and performance risks that are going to be personalized to that particular individual. And that's really important because one of the things that you really need to account for is looking at interhuman variability. You're also going to have within an individual, depending on like what day of the week it is, they could respond differently to that stressor. They could have had like more or less sleep the previous night. They could have eaten like really poorly, gone out drinking. Like there's all these different types of variabilities that could impact some of those readouts. This has already been previously mentioned, but coming up with more realistic operational exposures, that would sort of like feed into giving you stronger data for your model. Matt mentioned, and we had the same thought, that people tend to look at these stressors individually. They look at them in their own little separate box, but in reality, you're exposed to a complex mixture of things. Also designing our experiments to have a better dynamic range of exposure, because a lot of times, like when you're in the lab, you set things up for like 4, 12, 24, 48-hour time points. But individuals are not going to be stressed continuously for 48 hours to like one of these scenarios. So how do you incorporate like the kinetics of exposure in what a person is actually seeing? And then a last question that we thought would be interesting to address is when we talk about resiliency, are there things we can do to condition the cells in our body and like change like the molecular signatures to where you become less sensitive to stressors over time? And this would be great for things such as noise, G-force, and altitude, and ways to counteract that.